Graph the equation. Identify the vertex. Y equals the quantity x minus 3 squared. In order to identify the vertex, let's first rewrite this equation by squaring the right side. We have y equals x squared minus 6x plus 9. Now we can easily see the coefficient of x squared and the coefficient of x. The x-coordinate of our vertex is equal to negative b over 2a, where b is the coefficient of our linear term and a is the coefficient of our squared term. So x is equal to negative of negative 6 over 2 times 1, which is equal to positive 3. We can find the y-coordinate of the vertex by substituting 3 for x in the original equation, and we have y equals 3 minus 3 all squared, which is 0. This tells us that our vertex is the point 3, 0. Note that this is also an x-intercept because it crosses the x-axis at 3, where y is equal to 0. Now let's find some additional points on this graph so that we can more easily graph the equation. If x is 1, then y is 1 minus 3, or negative 2, squared, which is 4. If x is 2, then y is equal to 2 minus 3, or negative 1 squared, which is 1. And if x is 4, then y is 4 minus 3, or 1 squared, which is 1. Now we'll graph the equation. We'll first let each of the dotted lines on our axes represent a unit of 1, so that the maximum on each axis is 6 and the minimum is negative 6. And then we'll plot our points. We'll first plot our vertex, which is at 3, 0. So we plot a point at 3 on the x-axis. We then plot the additional points that we found. We have the point 1, 4, so from the origin we move right 1 and up 4. We have the point 2, 1, so from the origin we move right 2 and up 1. We have the point 4, 1, so from the origin we move right 4 and up 1. And we'll also note that our vertex at 3, 0 tells us that we have an axis of symmetry at x equals 3. We can draw a vertical dashed line at x equals 3 so that we can more easily see the symmetry. Our parabola will be symmetric over this line. And therefore, we know that because we have the point 1, 4, we also have the point 5, 4. Now we draw a smooth curve through these points to graph the equation.